What's up guys, this is Massey. Welcome to another video. In this video I want to talk about differentiation rules. Rule number 1 is derivation of a constant function. What does that mean, derivation of a constant function? You can say that if h has a constant value of c, then df over dx, which is the derivative of f with respect to x, is going to be 0. Because f of x is c, the derivative of c with respect to x is going to be 0. Let's see some examples. For example, when somebody says f of x is 8, find out the derivative, then you can say df over dx, which will be d of 8 over dx is going to be 0, because that's the constant number. We have a similar situation whenever f of x is, for example, pi over 2. So it means that df over dx is going to be the derivative of pi over 2 with respect to x. That's going to be 0. You have the same thing when the function is equal to square root of 3. df over dx is going to be the derivative of root 3 over x. That's going to be equal to 0 as well. Let's prove it. So for example, here I'm going to say the derivative, the formula is f prime, that's equal to limit of f of x plus h minus f of x over h when h is approaching 0. Now f of x is c, so you know f of x plus h is going to be c as well, because both of them are constant and they are not a function of x. So that's going to be limit of c minus c divided by h is going to be 0. So that's how you prove it. Other examples will be, for example, y equals to 7. The derivative of y with respect to x is going to be 0, because that's the constant number. Let's say if f of x is 0, what is going to be the derivative of f of x? It's going to be 0 as well. If you have, for example, g of t equals to negative 3, the derivative of g with respect to t is going to be 0. And, for example, if f of x is k pi squared and k is the constant, then again you can say the derivative of f with respect to x is going to be 0 as well, because in all these cases you're going to see we are dealing with a constant number. Rule number 2 is saying that power rule for positive integers, so it is d over dx of x to the power of n, that will be n times x to the power of n minus 1. So it means that the exponent is going to be as a coefficient, and we just reduce 1 from the n, so it's going to be n minus 1. For example, the derivative of x, since it's x to the power of 1, it's going to be 1 times x to the power of 1 minus 1, which will be 1 times x to the power of 0, and any number to the power of 0 is going to be 1. So the answer is 1. The derivative of x to the power of 2, that will be 2 times x to the power of 2 minus 1, which will be 2x. Derivative of x cubed is going to be 3 times x to the power of 3 minus 1, which is going to be 3x squared. The derivative of x to the power of 4 is going to be 4x to the power of 4 minus 1, which is going to be 4x cubed. And so on. If we have x to the power of 100, it's going to be 100 x to the power of 99. So that's the power rule for positive integers. So let's have a proof of rule 2. So if f of x is x to the power of n, f of x plus h will be x plus h to the power of n. Then you're going to say f prime x is going to be limit of f of x plus h minus f of x divided by h. So then it means that it's going to be limit of x plus h to the power of n minus x to the power of n divided by h when h is approaching 0. Now you need to expand this one. When you expand it, it's going to be x to the power of n plus n x to the power of n minus 1 h plus n times n minus 1 divided by 2 x to the power of n minus 2 h squared n x h to the power of n minus 1 plus h to the power of n minus x to the power of n divided by h when h is approaching 0. Now as you see here, these two cancels out, and if you cancel h with one of the h from the numerator, this one and this one, and with this exponent, and this one, n becomes n minus 1, n minus 1 becomes n minus 2, and when h approaches 0, all these terms is going to be 0. So the only term is going to remain is n x to the power of n minus 1. So that's the proof of rule number 2. Now let's see rule number 3. Rule number 3, it says, it is called constant multiple rule. If u is a differentiable function of x and c is the constant number, then d of cu over dx is going to be c times the derivative of u with respect to x. For example, f of x, if it's c times g of x, then you can say f prime x is going to be c times g prime x. Or you can say if f of x is c times x to the power of n, then f prime x is going to be c times, that's the constant part, times derivative of x to the power of n, that we know it from rule number 2, which is going to be n times x to the power of n minus 1. So it's going to be cn x to the power of n minus 1. If f of x is 3 x to the power of 3, f prime x is going to be 3 times the derivative of x cubed, which is going to be 3x squared. So 3 times 3, 9, so it's going to be 9x squared. Now, let's see the proof of rule 3. So if we assume that f of x is cu and u is differentiable, you can say d of cu over dx is going to be limit of cu times x plus h minus c of ux divided by h when h is approaching c. Then you can take c out, you can factor it, it's going to be c times limit of u x plus h minus u of x divided by x when h is approaching z. So as you see, this part is going to be this definition of derivative. So it's going to be c times du over dx. So that's the proof of rule number 3. Rule number 4, derivative sum rule. If u and v are differentiable functions of x, then their sum u plus v is differentiable at every point where u and v are both differentiable at such points. For example, the derivative of u plus v with respect to x is going to be the derivative of u with respect to x plus the derivative of v with respect to x. For example, if you have y equals to x to the power of 3 plus 12x squared, then u prime is going to be the derivative of this plus the derivative of this. The derivative of the first one is going to be, we had it in rule number 2, 3x squared, and the derivative of this one is going to be 12 times 2 times x, which is 24x. Another example, when you have y equals to x to the power of 2 plus 3, then y prime is going to be the derivative of this part plus the derivative of this part. The derivative of the first part is going to be just 2x, and the derivative of 3 is going to be 0. So y prime will be equal to 2x. Let's see the proof of rule 4. We have ux and we have v of x. We need to find out the derivative of summation of these two. So that's going to be limit of u x plus h plus v x plus h minus u of x plus v of x divided by h when h is approaching 0. So then we need to separate them. It's going to be limit of u of x plus h minus u of x divided by h when h is approaching 0 plus limit of v of x plus h minus vx divided by h when h is approaching 0. So that's going to be du over dx plus dv over dx. That's the proof of rule number 4. Remember, you can extend rule number 4 for situations that you have more than two terms. For example, if somebody asks you, find out the derivative of f of x equals to x cubed plus x squared over 2 plus 4x minus 3. F prime will be derivative of the first one. It's going to be 3x squared. The derivative of x squared divided by 2 is going to be 2 over 2x, which is going to be just x. Derivative of 4x is 4. Derivative of negative 3 is 0. So that's what we have. Rule number 5 is about derivative product rule. If u and v are differentiable at x, then the derivative of u times v is going to be u times dv over dx plus v times du over dx. So, how do we prove that? We can say d of u times v, that's going to be u x limit of u x plus h times v x plus h minus ux times vx divided by h. Now into that fraction, I'm going to add and subtract u x plus h vx minus the same thing because we don't want to change it. Then we can group them. We're going to say limit of u x plus h times vx plus h minus v of x divided by h plus v of x u x plus h minus u of x divided by h when h approaches 0. So that's going to be u x plus h times derivative of v with respect to x plus v times v x times du over dx. And since this approaches 0, we can say this one is going to be u of x dv over dx plus v of x du over dx. So that's the proof of rule number 5. Rule number 6, it's about derivative quotient rule. If u and v are differentiable at x and if v of x is not equal to 0, then the quotient u over v is differentiable at x. So the derivative of u over v is going to be the derivative of numerator, which is du over dx times the denominator minus numerator times the derivative of the denominator over the denominator to the power of 2. So if I write it in a more understandable way, it's going to be u prime v minus u v prime divided by v squared. So derivative of numerator times denominator minus numerator times derivative of denominator over denominator squared. That's the rule number 6. And if I want to prove it, proof of rule 6, that's going to be d over dx u over v. It's going to be limit of u x plus h over v x plus h minus u of x over v of x. H approaches 0. Then we have common denominator v of x times v of x plus h. It's going to be vx times u x plus h minus ux times vx plus h divided by h when h is approaching 0. Then what we can do, we can say, we can add and subtract vx ux minus vx ux. Then when you simplify it and bring this one down, it's going to be limit of vx ux plus h minus ux over h minus ux times v of x plus h minus v of x over h over vx plus h times vx. And when you simplify it, it's going to be, when h approaches 0, it's going to be v du over dx minus u dv over dx over v squared. Rule number 7 is about power rule for negative integers. If n is a negative integer and x is not equal to 0, then derivative of x to the power of n will be n times x to the power of n minus 1. For example, derivative of 1 over x is the same as x to the power of negative 1. So the derivative is going to be negative 1 times negative 1 minus 1 is going to be negative 1 x to the power of negative 2, which is going to be negative 1 over x squared. Or we have d over dx 1 over x squared, that's d over dx x to the power of negative 2. So the derivative is going to be negative 2 times x to the power of negative 2 minus 1, which is going to be negative 2x to the power of negative 3, which will be negative 2 over x cubed. Let's see another example. D over dx 4 over x cubed, that's going to be 4 times x to the power of negative 3, and the derivative is going to be 4 times negative 3 times x to the power of negative 3 and negative 1. It's going to be negative 12 x to the power of negative 4. Or you can say negative 12 over x to the power of 4 over 4. For this one, like this one, whenever you have negative exponent, you can bring it down and make it positive. Or like here, we have x to the power of negative 2, you can bring it down and make the exponent. So these are the rules we have for differentiation. I hope you enjoyed this video. I will leave some related videos in the description. In case you need extra practice question, you can just take it. I hope you enjoyed this video. Please leave me a comment if you have any questions. Thank you for watching and have a great day.